Hi, good morning. My name is Pandey. I am from Business Communication. Today we are going to discuss about the vibration systems. This is called the vibration apparatus. Before going to start the discussion about the vibration, we need to understand what is the vibration and what is the applications. Why we are here for the discussions. About the vibration definitions, if any mechanical body is moving from the one origin of axis from to and from the one axis, this is the called vibrations. Okay, then vibrations, like in anywhere in our real life, it's very important to study about the vibrations. Without a study of the vibration, without calculation of the vibrations, we cannot make the designing of the like aircraft, architectures of the building, bridge designing and many more. Like here one spring can be the one example to understand what is the vibrations. Vibration means, suppose this spring, we are keeping the one spring, this is called the origin of axis, and suppose if applying a force, then they will go either up or down. In the term of the physics, this is in the term of physics, either we can use the two principles to characterize this one. One is called the Newton's second law, energy conservation. We'll do all the characterization in the next of our slides. Second questions, why it is important for our discussion, why we are here for the discuss, because this is the first question arise, like why we are discussing in the vibration. Suppose we are going for the making the one breeze, and suppose if you are not making the proper calculations, then due to the vibrations, the different property arise in the materials, your body. Suppose if any body is moving from top to down continuously, if you are not find the what is the range of the vibration of the body, after some time this body start breaking from the material, because when they are going top down, then the molecules force they becoming less, after some time they will break down. Then we always try to calculate what is the sustainable vibrations so that it can work long time. For example, like aircraft designing and the automotive industry and building construction, like that can be the example of our vibrations applications, which always require to make the calculations. For example, I can take one example, like suppose we have the moving car, and if you are not make the proper calculation of the vibration, then suppose car moving from A to B point and it's going down, suppose it's going to H height, then we know the potential energy depend on the height, then they will gain the height. After when they will go up direction, they will transfer this energy from down to up. If you don't have the proper calculation in between, then this energy will be transferred to directly body, like we will feel heated by this down absorb energy. That the moving car designing can be the one example to understand why it's so important for us. In the next slide, I put some examples. For example, like suppose if anyone doing this hole here, then this due to this process, this vibration will be transferred to the other body. We have to understand that if you are not making the proper calculations of the vibrations, then the system, due to the system property, it will be generate the noise. So that this application to understand here about the fatigue property. Suppose if you are not doing the proper calculation in the breeze, we cannot survive this breeze for the long time. Like after this vibration, they will get break. Then always the construction engineer, they calculating what is the sustainable vibration for this one, so that we can use this property for the long time. Okay, these all are we discussed already application, but according to the physics, vibration we have to divide in the three parts. Generally in the physics we said that there are three kinds of vibration. One is called the free vibration, second point is called the force vibration, and third is called the damped vibration. In our setup, in our equipment, we are going to make the calculation of the three applications. First, we need to understand what is the free vibration, what is the force vibration, and what is the damped vibrations. In the next slide, I just put some examples to understand what is the meaning of the free vibrations. Free vibrations means, suppose anybody have the own natural, either anybody have the two property, either this body will be have the static, they have some moving activities. In case of the moving activities, they have some natural frequency to go and from the center of origins. After that, this point we call this is the natural frequency. For the natural frequency, in the other word I can say, suppose if I am not applying any force of this body and this body is oscillating from one point to other point from the one center of axis, this is called the free vibrations. That means in example we can say our pendulum can be the best example for the vibration. Suppose this is my pendulum and I fix this pendulum on the top side, it's vibrating due to the some external layer. But suppose we are not applying like intensely, we are not applying any force to this body, this is called the free vibrations. Like the pendulum can be the good examples. Next, there are some images here. I put it some example to understand what is the meaning of the free vibrations. In the next conditions, we are going to discuss about the force vibration. Force vibration means suppose any body have the equilibrium conditions. Either it will be in equilibrium conditions, they have the own natural frequency. In the both cases, suppose if I am applying the force and we are increasing the vibration of the body, then this is the called the force vibration. Suppose I am taking the example of the spring, because the spring is easy to understand, like the property of the vibration. Suppose I push this spring to some distance, for example x distance. After that, when they will leave, their body start moving to and from the center of origins. That cases, the one time we are going to get the higher frequency in the term of the physics. This is called the resonance frequency. This is called the force vibration. Means in the other terms, suppose any body had the natural frequency, they in the equilibrium condition. If applying the force, and leaving this force, the body will gain some energy. After that, they will start oscillate from the center of origins. This is called the force vibrations. And this all experiment, the all theoretical part, we are going to do with our equipment. In the next slide, I will discuss about the equipment. Next, about the damped vibration. Damped vibration means, suppose if you are applying the force to any body, then there will be a start vibration, there will start oscillations from the origins. After that, due to the external forces, either it might be like our air assist, either might be some liquid inside the moving part, they will stop the vibration after some time. This is called the damping vibrations. Otherwise, suppose if you don't have any opposing force in the environment, then this potential energy cannot stop. That's why we require the external force to stop these vibrations. Either example like breeze is vibrating with the natural frequency, then after some time there is no movement, there is no force on the top, they will get stopped. This is called the damped vibration. In our calculations, we are going to calculate about what is the damped vibrations. Damped vibration we are characterized in the three parts. Maybe we will discuss in the next slide. Okay. Generally, the damped vibration we are characterized in the form of the three parts. One is called the over damping, critical damping, and under damping. It is very important to understand what is the three meanings, and it is very important always in the real life to calculation of three damping conditions. If you not make during the designing, during the making process, if you not focus this part, then it will be very danger for the real life. Okay. Then it is important to understand what is the meaning of the damping conditions. There are three damping. The one damping factor due to the calculations, and in the second slide here there the formula like how we are going to calculate the damping factor and how we can understand what is the critical damping and the over damping. I have put the three graphs. Suppose any body is vibrating, either this body vibrating from the one angle, it can be the multi-angle of the vibration. That time, this is the equilibrium condition for the system. This is the equilibrium condition from the body, and this is they are going for the natural vibration frequency. After some time, the effect will be less and this vibration will be stopped. This the second line, this red line, this is called the under damping conditions. And critical damping means, suppose if you are applying the external force due to the mechanical effect, we are, after applying the force, the frequency of the vibration just in the single vibration they come into the stabilized conditions. This is the green line. This is called the critical damping condition. Other is the called over damping conditions. Over damping condition is the always dangerous for real life, and they can generate the different property for the material. Either it can be fatigue, it can be dangerous. This is called the over damping, which is always required to calculate in real life. Like they are not following the natural frequency, they are going the beyond of the natural frequency, so that the system cannot survive for the long time. Suppose they have the on frequency, but after some limit of the frequency, this part will get break, which need to discuss, we need to calculate in our experiments. Okay, the second slide, I just put the one slide. This is called the degree of freedom. This is called in any body they have the two kind of degree of freedom. Suppose any body I fix it here and they are moving from the same origin. This is called the single degree of oscillation. But the single degree of oscillation is not like fixed for the all body. Like we cannot say, I cannot say the all body have the single degree of oscillation. But suppose in case of the aircraft designing, in case of the automobile designing, bridge designing, you always have to consider this multi-degree of the freedom oscillation. Is not always required they will oscillate from the one axis. It can be the multi-axis, which is this part is very complex for analysis, but it's also important for understand. Next, we are going to discuss, this is our setup, like how we are going to study about the three parameters. For examples, like force vibrations, free vibrations, and the damping vibration. For that, our manufacturer, PA Hilton, they make the one setup to understand what about this vibration concept, so that a student can understand how the vibration is affected for our real life. For that, we are going, this is called the vibration module, and in our system the module is HBT1 to D. They have the 5 kind of experiments. In that experiment we are going to make the one, this is the how our setup is looking. In the next slide I have the descriptions. Okay, this is our setup. Just I put this a small body here, our equipment, this part I put it here, this part here, to understand about how we are going to make the calculations and understand about the all 3 parameters. For that we are making the first part. This part is called the frame part. After that frame we are putting the one beam in the middle of line. This is called the beam. We are putting the one beam in between inside the frame. After that, this is the beam part. This is the beam part, and we are fixing from the one corner. In the next of that, we are using the here. This is the list of the parts which I am going to describe. Okay. Then this total covering part, this is called the frame. The second in between line, this is called the beam, and downside we are using the sensor. This is called the LVDT. I will explain what is the LVDT. And this is the exciter motor. Why I am using the exciter motor? Because for creating the vibration in the system, I require the any moving part should be attached. Either it will be moving, it should be applying some forces there. Okay. Then next I am going to attach the one spring in the end of the beam, and downside we are putting the one liquid observer tank, so that when this motor will be rotated, they will create the vibrations, and our objective to calculation what is the resonance frequency, what is the natural frequency, how we are exciting this frequency, how they are effective. Overall, we are going to use this setup in our real life experiment also. Here, for controlling, to understand this last calculations application, we are using the one controllers. In the controllers have the power switch. After that they have the one display, so that we can see how much frequency we are exciting the system and what the effect they are giving. Suppose I am applying the 10 Newton force here, then how much force they are giving to the system and how they are observing the systems. Next, this in the back side of the controller, they have the many options. For example, they have the power connectors, they have the short circuit breaker. Suppose in case of any mishappening is happen, the suppose any short circuit happen in your circuit, yeah, they have the wrong earthing, they automatically they will trip down. That's your system is very much safe to use for the student. Next option is called the LVDT. I will discuss in the next slide what is the LVDT and why it is important for our discussions. Next is the called speed controllers and tachometer sensor. All I will discuss in our next slide. Next, I said what is the LVDT. First, we are using this sensor. In the some books it is called the transducer also, and in some book this is called the transformer. But we are using this LVDT. LVDT means linear variable differential transformer. In that we have this beam. I am going to put it here, the one LVDT. After that, when we are excite the body, either this beam will go up or down. Then this LVDT, this have the one magnetic core, and they are completely based on the principle of that. When this will vibrate, either it will go up or it will go down. That time they start get the output voltage. Then we can understand how the vibration they are affecting to our beam. For example, to understand the principle, how the principle is best, we are using the one primary binding here. Then we know from the Faraday's law. Like suppose if you have any inductance, the current is flowing, they will generate the magnetic field in the near to the environment. After that, this core is moving from top to from left, like minus x to plus s, for example. Then they will disturb the generating flux. After that, we are going to receive the flux